Okay, thank you. Yeah, and thanks for a great presentation from Urban Sharing. You mentioned cost there and some outages, and I would say that we have our fair share about outages as well in Geodata. So we are going to talk about cost calculation in a multi-tenant cloud-native environment. I'm Paul, and Ray here will also give part of this presentation. I will spend a few minutes setting the stage here and saying a few words about Geodata and why this is an important topic for us. And Ray will go more into the details on how we actually implemented this system. So Geodata, it's a fairly old company, established back in 1988. But the important part on this slide is when we put our first workload in production on AWS. It's actually back in 2011. And we put our first workload in production on Kubernetes back in 2016. Blindly, we didn't really know what we were doing at that time. So first couple of years were kind of exciting. I think the first year we ran without any metrics at all. And yeah, I learned a lot over those few years. We're working with many different business areas, and I would just like to highlight those in bold here, and why this topic is important to us. We have GIS content, like data that we sell and provide. We do have online services and also offline downloadable data. And we also have a professional services division here at Geodata and a managed services offering that they run. So the first workload we put on production in both AWS and Kubernetes were for this Geodata Online, our own internal product team. So that's where it all started. And then after a few years, the managed service also needed a way to host customer solutions. We got more and more demand from our customers to host their applications, their services, and their things. And we didn't have a very good place of putting that. But we had this platform that we built internally for our own purpose in this product team. So we spent some time and actually extended that to the whole company. So I will cover that a little later. So what do you run on this platform? We have hundreds and hundreds of services. Joachim down there can tell more about these services. He's head of the product department. But they cover everything from base maps to 3D buildings, search services, and yeah, everything in between, demographics, a lot of different content there. Back in 2019, when we have been running this internal or this platform for our internal product team for a while, our idea was to make this a core platform for the whole company. So we started the challenge of making our fourth generation of the platform. And we decided to make that cloud native. Up until this time, we had been using many of the AWS core services, the platform services. And it was kind of hard to extend that to the whole company when it comes to authorization, access control, and all these things. So cloud native, we started that project. And this is 3 years later. This is a snapshot from one of the production clusters a few weeks back. This is a multi-tenant cluster, and that's important to mention. Many of our development teams internally in Geodata run their own small portion of their stuff on this cluster. So we have 182 namespaces. At that time, probably more than 190 now. And some delivery teams have few namespaces, others has many. Yeah, just to give a picture of the size of the at the scale that we are running. And in total, the platform at an average business day, business hours, have approximately 80,000 requests per minute coming into our services. That goes through the core Nginx and all these other things. So we're using Kubernetes as the core of our platform, but of course the platform is more than Kubernetes. Kubernetes by itself doesn't solve much. It's like a state machine. This is the current state, this is the desired state, try to get from there to the desired state. But we need more than this for making a full-fledged platform internally, also back office system. So we're running a lot of add-ons. I'm not going to go through the complete list here, but Something worth mentioning is that we have built several in-house custom controllers and custom resources to help our teams be more efficient. So yeah, many things with storage, databases, and so on. And we also have built a back office system with dashboards where people can authorize themselves, download kube configs, get overview of their resource and assets, links to metrics and logs and all these things, and get like a higher level overview of their environment. So, and of course, this multi-tenant Kubernetes clusters is split into several sections when it comes to the hardware. We have many different node groups, which is handled differently. They scale differently. Some of them scale based on utilization, some scale based on requests. That's two very different things when it comes to Kubernetes. Scaling based on requests is not always what you would like to do. Some pods and workloads request like 2 cores, use 50 millicores. So you just scale by which metric. And some other node groups scale manually. We have different types of node groups. Some are on spot. Actually, most are on spot. Some are on demand. Some might have GPUs. Some have Intel. Some have AMD, ARM. Some have ephemeral disks. And of course, we are also updating these node groups differently. Different type of rolling update strategies per node group. So, yeah, and of course, we need observability and logging. Running the first year without any metric at all kind of give us some insight that we need to do better than that. So the de facto standard today is based on the Prometheus operator. I would imagine many people out there running Kubernetes or any workloads on Kubernetes have seen Prometheus or a Prometheus metric. But we have extended Prometheus with actually now Mimir, previously Cortex, to have scalable metric paths. We also use Grafana Loki for logging and log querying. So the Grafana Mimir and Cortex is the core of our metric system, which our billing and cost calculation platform is built on top of. That's why I'm mentioning this. Yeah, the previous slide there. So we have an injection rate about 150,000 samples per second to our metric platform. And when I took the screenshot a few weeks ago, about 5.4 million active time series, and about 300 requests for query per second. So to handle that, you need to have something more than just Prometheus. Prometheus doesn't scale to this level. It will eventually run out of memory on a single node. So that's why we're using Cortex and Mimir to be able to scale our metrics platform and the logging platform with Loki, which is very similar. So the challenge for us, how should we calculate the cost for all these things? This is a multi-tenant cluster used by many different teams in Geodata, having their own customers and their own workloads, their own business models. Some of the workloads are utilizing AWS native resources like S3, ECR, network load balancers, RDS. Even if we run most databases inside Kubernetes, we also run someone outside. And then we have network costs. That's something that you really need to pay attention to. It's easy to forget when you are not at scale, but suddenly the network cost becomes a huge thing for you. The egress cost and also moving data between the different zones is very expensive. We have storage, and yeah, we also have like shared resources like the observability stack, the ingress engines, the back office thing, logging platform. How should we split that cost? And also have node groups with different characteristics and scaling policies. So what is the total cost for a namespace for a month? That's the challenge we need to find out. So Ray Hill, we're going to go more into the details, how we actually did that to get the overview of the total cost per project. So Ray, click yourself.
First things first, is this working at all? We have a headset. That's excellent. So in the cloud native universe, when you need something, you go to the internet. We did that. we found cube cost. I have no idea where everyone in the audience here is, but cube cost, I mean, does anyone ever heard of it? Well, you've heard it at the scale where you use this. Maybe you've deployed it? No? Well, okay, that's good. So we have a lot to say. We have all new information to you. Cube cost. We find my mouse here, my arrows. Yeah. So it's kind of open source. They call it open core, I think. I think that translates as it's on GitHub, sort of. Produces cost numbers. It has graphs. It can produce costs for resources outside the cluster. They support your physical machine room if you have one. You have to configure it, obviously. It actually solves all problems you've ever had. As you might have seen on the previous slide, it solves a lot of problems. I mean, it's not really my style, but I mean, they've solved a lot of problems. I mean, we really like their network metrics. They have a little agent which runs on all your nodes, all 100 and whatever nodes we've got, and it looks at every single bit of communication between all your pods, and it looks at the IP where it's going to, and actually I guess not where it comes from, where it's going to, and you configure it to say these IP ranges are inside your zone. These IP ranges are crossing a zone. These IP ranges are crossing to another region, and everything else is going to internet. And that actually matters. Now, I don't know anything about Google Cloud or Azure. It turns out I'm hopelessly ignorant. I only know about Amazon. But on Amazon, that really costs a lot of money. I don't know if anyone's played with this. If you have some pods, which we've done this. We had this really cool storage system on Ceph. And it synchronized everything, all 3 AZs, like several times, and holy crap, they got to be expensive. And you wouldn't think that because you weren't even leaving the region, right? This was in Stockholm, but man, that was expensive. And the Amazon doesn't really tell you. I mean, you can just about be buying thumb drives and shipping them. It is really expensive, like physical media comparable price. It is shockingly expensive. So. Cube cost. Well, we didn't really like it that much. The dashboard is proprietary and it's got some data store. And I don't know. Paul knows more. He's more really our Kubernetes guy. It's all proprietary. Now I don't know why you would do that. And if you want to store more than 30 days of data, you have to pay them money. And I mean, I understand they have to earn money. They have to feed themselves. But it's pretty annoying. Grafana and Prometheus are really good. If anyone here doesn't know what those are, you should. They're really good. Metrics, logs, your friends. And so, yeah, it's really weird to have KubeCost decide not to use that. And it was near real-time data, but when you started a node, like on the spot market, again, I know nothing about Azure or Google, but on Amazon, you have the spot market, and the price kind of floats in theory, even though they kind of nailed it down so it doesn't. But they, so it starts a node and you have workloads on there and you don't know what it cost. But they're giving you real-time data anyway. So they kind of fake it. And also they split the CPU and RAM cost kind of arbitrarily. Now you can ask, it's kind of a useful question. You have a pod, it's running, and you want to communicate to the user. You're using too much CPU, using too much RAM, but on the other hand, it's on physical hardware. It has one price, so you don't really buy them separately. So it gets kind of complicated. I'll get more into that. And they were weird with how they did idle capacity, and they charge different money depending on where your pods ended up, which you may have in fact, you probably have a heterogeneous pool of machines. So we learned stuff from that. Oh, I should add, I started drawing in Paint, in Microsoft Paint, with these Lenovo, touch, what do they call the eraser, the track point, and so this is all track point art in Paint. So I had to do something to make it, not just a black and white slide. Prometheus, it turns out, is really cool. And if you plug in a few things to generate some metrics on top of the metrics which are already there, you have a huge amount of information about what's running on your cluster. A huge amount. I've written it there. You could read that, I guess. But detailed information, sampled like, I don't know, every minute, every 5 minutes, I don't know. Often 30 seconds, a lot. It's a huge amount. And Amazon, it turns out, has this cost and usage reports, which has got an acronym, and they will give you all the amount of money you spent on things. And again, gruesome detail. You go and you review these reports. They have so many columns. Your scroll bar is just going and going and going and going and going, and most of them are empty. It turns out it's kind of funny, but for different services, they'll have something in each column. Anyways, this enormous amount of information you have if you care to look it up. So we also know how to use the APIs. So, yes, this is the spirit. Power to the developers. Let's do it. So we did it. And here are some metrics. Grafana is the best. These names are a little hard to interpret, some of them, if you don't know them, and probably you don't know them because they're kind of niche. And derived metrics are useful. We'll get more into that. They come from different sources. I really don't know where we're at with everyone, but you generate metrics. You can generate your own metrics. You publish metrics. It scrapes it into the system, and so that's also occurring here. We have kubestate metrics as a package you install. That was on Paul's enormous list. We have kubelet, which I guess is the core of all the goodness, and we have kube cost is hanging out there with network cost. So we do use a little bit of kube cost. This is a free component. Yeah, so that's where we get our data. And here's a derived metric. You don't really need to remember exactly what that says, but the point is that you have this query statement thing, which is actually really disturbing, I find, coming from SQL. I find this really weird. I don't know, is it weird? Anyone? It's weird. It's really strange. But anyway, it runs this continuously and dumps it into new metrics. So it's like a sausage machine. In goes metrics, out comes metrics. And once you've made it, you can read it a lot of times at high performance, which is kind of nice. And you saw on Paul's slide we had, 5 million active time series. Yeah, okay, the difference between a metric and a time series, you have a metric, and inside the metric you have a whole bunch of time series. Each combination of labels will give you different time series, right? So we have 5 million time series. I don't know how many metrics, doesn't really matter. Anyway. Yeah, so it's not like everything was just paved and done for us. Prometheus is really cool, but you can lose your data at times, and so if you're using that for anything, there'll be holes in it. You have to be able to deal with that. And Amazon, it's really nice data, but they update it in these huge blocks that kind of semi-randomly, and they do it whenever they feel like it. Like I was mentioning, it's you have to wait for it. So we're very interested in EC2 instance costs. That's where a lot of money goes. And so you start your EC2 instance, or it scales itself. Let's say on the 59th minute of an hour, right? And it doesn't start doing useful work, maybe, 3-4 minutes later, 2 minutes, whatever. Anyway, so it's in the next hour. And this bill, your cost shows up in the hour it started, but you don't get anything out of it until the next hour. So you've got to be okay with that. And then whenever you shut it off, the last fraction is always at the end of the hour, even though it's gonna not really align with reality. Again, it's probably going to be, it'll be off in space after the point you actually stop using the instance. So you have to be a little clever. It's just had to deal with that. And here is, it's beautiful. Look at that. Oh, look at that beautiful graph. This is expense data. Yep, looking good. Once a month, it goes up from a small number to a big number. It does this not going down because you don't earn money on Amazon. And actually, this is beautiful anyway. You couldn't, this is a Grafana graph, I should say. So we can actually use this in any dashboard you want and present it in all sorts of ways. It's lovely. You didn't have to pay any kind of weird fee to some business to, suffer through extracting this from their product. And as you can see, it's got all kinds of problems with it, which is fantastic. You can see that we had errors and we continued. This is really excellent, actually, because you will have errors. You will definitely have errors. This also goes back to about when we were developing it. We haven't been running this that many months. 6 months? 6 months? Everything happened, I mean, 6 months, that's a long time, right? That's a long time. Yeah, now I get into the fun business of how do you calculate cost. I mean, I don't mean to, hopefully it's not really too boring. We want to have those graphs that go up. They start low and they end high. We want to have drill down, so a project manager can say, what happened to my budget, right? That's a good question. I mean, and Paul and I and the team, we're like, your problem, right? Go find out yourself. So one thing we did different than KubeCost is because node groups. Paul's talking about node groups, right? When you're at scale, you're going to have groups of nodes which have similar properties, scaling behaviors, for example, and maybe hardware properties. Maybe they're weighted towards CPU, or they're on demand, or they're on spot, or whatever. Anyway, so we treat the whole thing as a big pool, and we don't penalize the pod that happens to be the first pod on an instance, or the last pod, or whatever. And it depends on the node group. We have different behavior, whether it's just usage data or the maximum of usage and your request. And idle costs go into the node group. This is, again, different than KubeCost. We make up the CPU RAM split as we go. That's kind of a personal preference matter. So it's probably a little boring. We don't want to probably talk about it too much, but you poll Amazon, and then eventually they come with some data for you, and you start out by finding out your price for a node group, and then you find the hourly price for an instance. And we don't ever actually look at the total price for an instance, because as I was mentioning, that is offset. The time in which the instance is billed does not really match, because you're going to learn from your metrics when you actually had pods running on the instance. Back a few slides, right? You have a metric which says this pod ran on this instance, and that instance is part of that node group, and that pod used this much RAM, and that pod used this much CPU, and it requested this much and that much. You have all the information, but Amazon is only telling us the actual price per hour. And we don't care what it is. We completely ignore the hardware. We completely ignore whether it's spot or not. We don't care. But we also have a metric which says how much RAM there was, how much CPU was. These are kind of weird metrics, and they are completely flat, if you believe it or not. A machine does not have like increasing RAM or decreasing RAM. It has a certain amount of RAM, but they keep publishing it every 30 seconds for the whole lifespan of the machine. It's great. So we go through Prometheus data every 60 seconds, just at this fine grain level, and we say, at this 60-second slice, what's running? Where is it running? How much does this all cost? And we do this. And I have a slide talking about that next. And so at the end, we distribute any costs that leaked past that stage, for example, due to your Prometheus data disappearing. That, as I mentioned, that happens. And then we write it out to a Prometheus scrape target. Then so each 1 minute interval, we're looping on the data. Actually, I just talked about this stuff. It's funny. So let's start with the node group. Oh, we go faster. That's good. I was worried about not having enough to say. For each node group, you look at how much is running there because you have all that metrics. You see how much CPU and RAM demand there is as like a percentage. You then, from that usage, you determine what demand there is. And from the demand, you determine the price. And then you pass it on to the pods. Yeah, that was fast. The details of how you do this are very arbitrary. You might decide anything you can imagine is actually a cost driver. It has to do with your risk, your preference. You just make it up, right? And this is what we did. We made it up too. This beautiful hand-drawn diagram in the corner is depicting our current algorithm, which is really brilliant. If you have 50% so total you have 150% of something being used, you put it all together and that splits to 1/3 and 2/3. It's really cool. Total rocket science, but it changes every minute for every different node group. So you have this floating cost. If someone is coming along using a lot of CPU and you have a lot of free CPU, it's relatively cheap for them. And there's some stuff that's describing what I just said. So, yeah, and when you've implemented this and you find out if it actually runs, it turns out it's very accurate. We were coming in like 99.9 something % accurate on the Amazon prices just by taking those sampling every 60 seconds and looking at the expected price. Very accurate. And I don't know if you use Prometheus scrape targets, you can in fact write 500,000 of them, time series with a single scrape target, and it'll be scraped and it'll work. I don't know, is anyone impressed? I mean, maybe we don't write enough time series. 500,000 of them, and they're all, I mean, that's like megabytes and megabytes of just gruesome text. And you should probably split it over a few scrape targets for durability. Yeah, there is a data delay, and you'll be fine probably if your data is next day. And so then there's a few more crumbs, which are easy to summarize. Storage network Paul was mentioning, you have to also get those, but they're easy to get. Everything gets boiled down to these increasing graphs that reset at the end of the month. And this was done in about 2,000 lines of Python and some stuff. So it's really not that bad. It's just, there's a few bugs on the way. But.
Yeah, and then the end result would actually be something like this. This is our cost calculation dashboard. This is used by our financial department as well for taking out reports and then tagging the cost for the right project. So as you can see here, we have some of the projects listed, and we will get the cost for the auto-cluster resources like S3, RDS, container registries, and all these things. And also you have the CPU and memory, which are the main metrics that came out of the system that Ray described right now, and the cost for that, and what would be the cost per project until this time in the month. And then we have some interesting things, which are the shared costs, like what does the platform actually cost this customer and this project. So based on the ratio of use of CPU and memory for your namespace compared to all the namespaces, we give you a share of the platform cost as well. And the same for the storage, we bill you or you track the cost based on the bytes consumed, not requested, because it's in provision and all that in the storage. So basically, you only pay for what you used, not for what you ask for when it comes to the storage. So at the end, you get a number, and that's what the project manager would like to have, so they know how much they have spent over the last month for their workload. So yeah, guess that's it then.